In this video, I want to look at the other trig functions, tangent, secant, cosecant, and cotangent. And I'm going to just look at their basic graph and some of the properties, but you can use Desmos or something similar to kind of explore what happens if you multiply by different numbers or add or subtract different numbers at any point in your function. Let's start with the graph of tangent x. So here I have a representation of the graph of tangent. The domain is all of the intervals of the form k pi over 2, comma k plus 2 pi over 2, where k is an odd integer. In other words, it goes from negative pi over 2 to pi over 2, from pi over 2 to 3 pi over 2, 3 pi over 2 to 5 pi over 2, etc. The range, on the other hand, is negative infinity to infinity. It could be outputted to any value along the y-axis. I do have vertical asymptotes here. These asymptotes occur at k pi over 2, where once again k is an odd integer. So the function actually does not exist at pi over 2, 3 pi over 2, minus 3 pi over 2, negative pi over 2, etc. I have x-intercepts at negative L pi over 0, where L is an integer, so intercepts at negative 2 pi, negative pi, 0, pi, 2 pi, etc. My y-intercept occurs at 0 to 0. And the period here is pi. It repeats every interval of length pi. So for instance, negative pi over 2 to pi over 2. It's the same thing as pi over 2 to 3 pi over 2, etc. Next, we have the graph of secant x. This little dotted line down here, this is the graph of cosine of x. So some of the properties here. Just like with tangent, my domain is of the form k pi over 2, k plus 2 pi over 2, where k is an odd integer. The range goes from negative infinity to negative 1, and then 1 to infinity, so I kind of have this gap between negative 1 and 1, where no values are hit. I have these asymptotes at k pi over 2, where k is an odd integer. And we'll notice that these asymptotes occur where the graph of cosine actually crosses the x-axis. Where the x-intercepts of cosine occur, the asymptotes of secant occur. My y-intercept is 0, 1. I cross the y-axis at 1. And I can see that I have no x-intercepts. Finally, I can see that the period is 2 pi, just like it is for cosine. Next, I'm going to look at the graph of cosecant, and this time this dotted graph down here is the graph of sine x. My domain is all the intervals of the form L pi, L plus 1 pi, where L is an integer, so 0 to pi, pi to 2 pi, 2 pi to 3 pi, etc. Just like with secant, my range goes from negative infinity to negative 1, and then picks back up at 1 to infinity. I have this gap between negative 1 and 1. My asymptotes are at x equal to L pi, exactly where sine of x has its x-intercepts are where the asymptotes occur in cosecant of x. And we can also see that this graph actually doesn't have a y nor an x-intercept. So this graph doesn't have any intercepts. And the period of cosecant of x is 2 pi. Finally, let's look at the graph of cotangent, and this red one this time is tangent of x. This time my domain looks like L pi, comma L plus 1 pi, where L is an integer. In other words, things like negative 2 pi to negative pi to 0, 0 to pi to 2 pi, etc. The range is negative infinity to infinity. I can output any number. I have my asymptotes at x equal to L pi, so asymptotes at negative pi, 0, pi, 2 pi, 3 pi, etc. I can see I do not have a y-intercept, but I do have x-intercepts. My x-intercepts are of the form k pi over 2, 0, where k is odd. So these correspond to the asymptotes of tangent. Where the asymptotes occurred before are now my x-intercepts, things like negative 3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2, etc. And just like with tangent, the period of cotangent is pi.